Right now, an object you can see with your naked eye is deciding whether your descendants live on a planet with seasons at all. It has been doing this for over 4 billion years. It is doing it today. Almost nobody on Earth knows their entire civilization exists because of it. The strangest part isn't that it's happening, it's how quietly. There's no headline, no flash in the sky, no single night you could mark on a calendar. Just one companion out in the dark, holding our planet steady with a patience that makes human history look like a single afternoon. So let me show you the machine that has been stabilizing the seasons. The machine hanging in plain sight every single night. Start with a fact that should not be true, but is. Earth's axis, the tilt that gives us seasons, is wobbling far less than it should. A planet spinning alone in space, with no large moon, does not hold its tilt steady. It tumbles. Slowly, chaotically, over millions of years, the axis swings wildly from nearly upright to lying almost on its side. We know this because we can watch it happen to our neighbor. Mars, with 2 moons too small to matter gravitationally, has an axial tilt that has swung between roughly 15 and 35 degrees over the last few million years. Earth's tilt moves too, but only by about 2.4 degrees, oscillating gently between 22.1 and 24.5 degrees on a slow 41,000-year cycle. That is the difference between a planet with stable seasons and a planet with climate chaos. Something is holding Earth steady, and it is not Earth itself. The answer came into focus through a landmark 1993 paper by French astronomer Jacques Lascar and his colleague Mireille Gastineau. They simulated how Earth's spin axis would behave under the gravity of the Sun, the planets, and our Moon. Then they ran it again with the Moon removed. The result was unambiguous. Without the Moon, Earth's tilt would not stay in its gentle range. It could swing by more than 60 degrees over millions of years. The Moon is not a passive rock reflecting sunlight back at us. It is an anchor. Here is why that anchor works. Earth bulges slightly at the equator, a flattening caused by its own rotation. The Sun and Moon both pull on that bulge. Because Earth is tilted, that pull acts at an angle, creating a twisting force called torque. This torque makes Earth's axis trace a slow circle through the sky every 26,000 years, a wobble called precession. On its own, that precession would be harmless. The danger comes from resonance, the same effect that lets 2 children pump a swing higher by timing their pushes perfectly. Earth's precession rate sits dangerously close to frequencies created by Jupiter and Venus tugging on our orbital plane. If precession ever drifted into alignment with those frequencies, small wobbles would compound into large, chaotic swings instead of canceling out. The Moon prevents this by speeding up Earth's precession just enough to keep it clear of that danger zone. Without the Moon's added torque, our precession rate would drift directly into the resonant chaos that destabilizes Mars. Mars is the natural experiment we cannot run on Earth. Its moons, Phobos and Deimos, are tiny captured asteroids, far too small to stabilize anything. Geological evidence of Mars's ancient polar deposits suggests its axis has shifted dramatically over its history. Earth came extremely close to a similar fate. Lascar's models showed the chaotic zone Mars sits in is not far from where Earth's precession would land without lunar stabilization. We are standing right next to the edge, held back by a single anchor roughly 1/4 our own planet's diameter. Now consider how unlikely that anchor actually is. Our Moon is enormous relative to Earth, about 27% of its diameter. No other moon in the solar system comes close to that ratio next to a rocky planet of similar size. The leading explanation for its formation involves a collision almost too violent to take seriously. Roughly 4.5 billion years ago, a Mars-sized protoplanet, often called Theia, struck the young Earth at a glancing angle, vaporizing portions of both bodies into a ring of debris. That debris accreted into the Moon, according to some simulations, in as little as a century. If the impact angle had been slightly different, the Moon as we know it might never have formed at all. Earth's climate stability is, in a real sense, the product of a near-catastrophic accident. This stabilizing effect does something else rarely discussed. It protects the slower climate rhythms, the Milankovitch cycles driven by Jupiter and Saturn's pull on our orbital shape. from being overwhelmed by a chaotic tilt underneath them. The Ice Age clock recorded in seabed sediment and polar ice only works as a reliable beat because the baseline tilt is not also swinging wildly. Remove the moon, and that orderly rhythm dissolves into noise. The moon doesn't create the rhythm, it makes the rhythm legible. This has become a serious factor in the search for habitable worlds beyond our solar system. When astronomers assess whether a distant planet could support stable, long-term climate conditions, the presence of a large stabilizing moon is now one of the variables under consideration. A planet in its star's habitable zone is not automatically a stable one. Without a companion massive enough to anchor its axial tilt, even a perfectly positioned world could swing through climate extremes too severe for complex life to ever take hold. Let me be honest about the timescales, because this is exactly the kind of fact that gets exaggerated. The moon is drifting away from Earth by about 3.8 centimeters every year, confirmed by laser reflectors left on the surface by Apollo astronauts. But the timescale for that drift to meaningfully weaken its stabilizing grip is measured in hundreds of millions to billions of years. This is not a countdown clock for anyone alive today, or for thousands of generations after them. But the unsettling thing was never the speed. It's the dependency. Every stable season, every predictable winter that allowed agriculture to exist, every long stretch of climate calm that gave evolution room to build complexity, rests on a gravitational relationship we did not create and do not control. We are tenants in a house whose load-bearing wall is debris from a collision that nearly destroyed our planet before it became ours. Pull all the way back and look at what has actually been uncovered. One companion, formed from violence, holding the axis of an entire world steady against forces that have left our nearest neighbor tumbling through climate chaos for millions of years. A stable tilt we inherited not because we earned it, but because debris from an ancient collision settled into exactly the orbit needed to anchor us. A quiet gravitational machine that started working before life existed here, and will keep working for hundreds of millions of years after, indifferent to anything that ever looked up and noticed it. The moon is not doing anything dramatic in this exact moment. No impact, no eclipse, no event you could film. It is doing something quieter and far heavier than any of that. It is holding the axis steady. We are incredibly fortunate. We live beneath the protection of an object with no awareness we exist, that would not notice if we vanished, that will go on anchoring Earth's tilt for eons after the last of us is gone. But we figured out the mechanism anyway. We pulled it from orbital simulations and Martian comparisons and the geological record of our own planet, and understood for the first time just how much of our stable story has always depended on a piece of shattered protoplanet we will never fully appreciate. That's the part worth carrying with you after the screen goes dark. Not fear, not doom, just the quiet knowledge that the steady sky your ancestors built farms and cities under was handed to them by a violent collision 4.5 billion years ago, and a moon that has been holding the line ever since. Thanks for watching, and I'll see you in the next one.